Alright, so this is lesson 36, constructing arithmetic sequences. We're going to start the next lesson. So the objective for today is I will be able to analyze sequences and identify and write arithmetic sequences. So kind of the same thing as we've been doing. So for example, we've been looking at sequences like these: 5, 10, 15, 20, 25, right? And it could keep going on forever, yes? What would the next number be? Which one?
30.
30, right? Because it's going up by what every time? 5, right? So there's something called the explicit formula. If I put in a number to the explicit formula, you get the exact output for that number. There's also something called the recursive formula. Here's the idea for recursive, okay? So it's going by 5s, right? Does that make sense? So 5, 10, 15, 20, 25, 30. Okay, so let's just say I told you that the 20th number in this whole sequence is 100. What's the 21st number?
125.
What's that?
105.
105. That's right. How did you get that?
Follow the rule.
You just followed the rule, right? You knew that the 20th was 100, so you just add 5 to that, and it was 105. Does that make sense? Or here's another one. Let's say you're like, the 30th number is 150. What's the 32nd number? What? 160, right? 160. Okay? Good. So that's what we're doing today. We're going to write an explicit formula and a recursive formula on these numbers. If you're on the video, here are some terms. We talked about the recursive formula, but it's a rule for a sequence in which one or more previous terms are used to generate the next term. So it's kind of like we're thinking about one term and then generating another one. And then arithmetic sequence, we already know what that is. It's a sequence whose successive terms differ by the same non-zero number. And then there's a common difference, which is, we already know what that is. It's like a common amount, like 5, 10, 15, 20. It's always changing it by 5. That's a common difference. Okay, and we're going to talk about these two rules down here. Okay, but here are the steps for what we're doing today. If you are on the video, please pause here and write down the steps right here in the center. Alright, and we're going to move on. Okay, so here we go, numbers 1 and 2. So here's the sequence: 84, 100, 116, 132. What's happening at each number, everyone? It goes up by 16, right? So I'm adding 16 each time to get the next number, right? I'm adding 16 to get the next number. I'm adding 16 to get the next number. Y'all see that? Okay, good. So then we're saying our common difference is 16, okay? We could also say that the first number in the sequence is 84, or f of 1 is 84, okay? Or another way we could say it is, like, another way of saying f of 1 is like, we could say the first number, a sub 1 is 84. It's the same idea, it's just, this is the first number, okay? F of 1, a sub 1, the same idea, okay? Different way to write it. Or f sub 1, we're just saying the sequence is, the first number is 84, okay? So now we're going to go to step, we've labeled step 1 and 2. F of 1 is this number, 16. I'm sorry, the difference is 16. First number is 84. So now we're going to go to step 3, substitute the values in to find the recursive rule. So the recursive rule is kind of like, it is what it is. It's we're going to do our recursive rule right now. Okay, so we're going to write this down. And we got f of n. We're saying any number in this series, or sequence, I'm sorry, is going to be f of n is equal to f of n minus 1. Okay. Plus d. In this case, our difference, or d, is 16. So we're going to add 16 here. Okay, and that's our recursive rule. And what does that mean? It just means I can go to any number and add 16 and find the next number. So, like, for example, we know the fourth number is 132. What's the fifth number then? How would you figure that out? Well, you take the fourth number, 132, and add 16, which is 148. That's what the recursive rule is. We're thinking like recursively. Thinking, where were we? What's the next number? Okay? Then we're going to do the explicit rule. So you have to know how to create an explicit rule, which is a little bit confusing, I know, when you have a lot of different things you have to know. But we're going to practice this a lot. So the explicit rule, same thing, step 4. We're going to start with f of n. We're going to say any number in the sequence is equal to f of 1, which in this case f of 1 was 84. So we're going to put in 84 right here for f of 1. And then we're going to say our plus our difference. Our difference is 16. Open parentheses, n minus 1. And that's it. Okay? You box your answer, and we are done. Okay? This rule is like we could say whatever number we want, we can use this. So let's do f of 5. 84 plus 16 times 5 minus 1. What's 5 minus 1? 4. What's 16 times 4? 64. 64 plus 84 is 148. Same answer, right? Okay? So that's number 1. Let me do this one more time really quickly on number 2. Okay, number 2, I got a sequence here. And it's given to me in a table. We're saying that these are the terms, 1, 2, 3, 4, 5, and then these are the numbers, right? So on these numbers, what am I noticing? It goes 35 to 32, 32 to 29, 29 to 26. What's happening each time, everyone? What's that? We're doing minus 3 each time, right? So we know our difference is not going to be positive 3, but negative 3, okay? Our f of 1 is going to be equal to 35, okay? That's the first term. Then we're going to do, I'll use a different color here, recursive formula, okay? Okay, putting in the recursive formula, we got f of n. We're here on step 3. F of n is equal to f of n minus 1 plus our difference. And our difference is negative 3. So when I'm adding a negative 3, I'm really subtracting 3. So I'm just going to just rewrite this as minus 3. Okay? And that's it for the recursive formula. And the explicit formula is next. Okay, explicit formula now. We're going to write this down as f of n is equal to f of 1. Our first term was 35, we said. We're going to subtract d, or we're going to add d, which is really like we're subtracting 3. And then we got multiplying that times n minus 1. And then we're done. Okay? We box our answer here. Does that make sense, everyone? Okay, good. That's all we're doing is creating these two formulas today. Okay, because we can use them. Alright? So, do things a little bit differently today. It's Monday. Let's have Forrest start. Let's have Forrest teach the rest of their groups about number 1. If there isn't a 4, let's have a 2 talk, and then let's have a 3 talk about number 2. If there isn't a 3, let's have a 1 talk, okay, for them. Ready, set, go. So number 1, you should have this written down, but number 3. Another way you could see is you could say a sub 1 is equal to 100 still minus 12 times n minus 1. Same idea. All we're doing is we're just changing. You see, instead of f of n, it says a sub 1. Okay? Same thing. Okay? And that's it. Does that make sense?
Yes.
Yeah.
Okay, good. So we could use this formula, either of these two formulas on the explicit formula to figure out any number. So let's do the, let's say this was our set of numbers. Okay, let's do the 6th term. Okay, ready? F of 6, or a sub 1, a sub 6. What's 6 minus 1 here? 5. What's negative 12 times 5? What's negative 6 times 5? What's negative 12 times 5? Negative 60. Good. So 100 minus 60 is? What is it? 40. Okay, does that make sense? That's how we use the explicit formula. Okay? Alright, anyways, let's keep going here. Number 4, let's have you do this one all the way through by yourself. And I will call on you to give me the answer. Ready, set, go. Okay, what is our f of 1? Or if I said, what's a sub 1? What's a sub 1, everyone?
58.
Good, 58, good. What's our d?
7.
What is it?
Positive 7.
Positive 7. Thank you for saying that. Okay, good. What is our recursive formula?
F of n equals f n minus f of n minus 1.
Okay, so you said f of n is equal to what?
F of n minus 1.
Plus 7. Good. All right. That means we can figure out any number by looking at the number before it and add 7. Good. And then our explicit formula?
F of n equals 58 plus 7, and then n minus 1.
Okay, so we said f of n is equal to what?
58.
58.
7.
Good. That's it. Like that?
Yeah.
Good. Does that make sense, everyone?
Wait, for the recursive formula, don't you need to have for n is not greater than or equal to?
Yeah, we could put that in. We want to make sure that you can only use it when n is greater than or equal to 2.
Do we need it or no?
No, you just have to have that assumption. Because if you put 1 in, then you get 0, and 0 would not work for this type of formula. Okay? That's it. Okay. Let's see how you do this. That was the last full one. I want you to tell me what's the difference with your group. Okay? These look kind of weird. Look at the pattern up here. Eyes up at the screen. Working with your group. What is the f of 1 and the difference, or d? Ready, set, go. That's all you have to do, or these two.